the homework to lesson 3. So for number 1, it says rewrite each expression in the form kx to the p power, where k is a real number, p is an integer, and x is a non-zero real number. So really we are just condensing this down and simplifying it so that it is one single x term. So for A, first thing I would take care of would be the -2 on the outside of the parentheses. The 2x cubed does not have anything outside the parentheses, so it can just come down. Same with the 3x to the 5th. But the -2 can get distributed. So we have 6 to the -2, and now x is to the -2. From here, all the numbers I would type into my calculator. So on my calculator, I would type in 2 times 3 times 6 to the -2. And when you get the decimal, math enter, enter, and we're going to make it a fraction, 1/6. For the x's, they are each getting multiplied, so we're going to add the exponents. So 3 plus 5 minus 2, we should get x to the 6th. You can leave your answer like this, or if you want, that x to the 6th can go on top of the fraction, and you get x to the 6th over 6. Part B, we're going to start the same way. Anything that is outside of a parenthesis has to get distributed in. So the 2 on top is going to go in. We end up with a 3 squared, and x to the 8th, we want to multiply together exponents. On the bottom, distributing the 2, the entire -6 gets the squared, so you do need it in parentheses or it will be incorrect. And then x to the 2nd. For the numbers, I would again plug into my calculator. We're going to have 3 squared divided by -6 in parentheses squared. You get 0.25, but for these we really should be making them into fractions, 1/4. And now you're dividing, so we subtract the exponents. So 8 minus 2 gets me 6. You can leave it like this, or similar to A, you can put the x to the 6th on top and get x to the 6th over 4. For C, there's no parentheses that we have to worry about. So the first thing we should do is condense the top. So we're going to add those exponents. So we get x squared over 3x to the 4th. The x squared on top has a 1 in front of it. So the 1 over 3 is just 1 over 3. And then again, just like on the last one, we're going to subtract our exponents. So we get x to the -2nd. For this one, they didn't say that your exponent had to be a positive number, so you could leave your answer like this. Or if we wanted to make it positive, we could do 1/3 times 1 over x squared. Or you can make it one big fraction, 1 over 3x squared. All three of these mean the same thing. For D, the 5 is on its own for right now. Power to a power, 2 exponents, we multiply. And then the last one needs a little distributing. The 2 gets the -4, and the x gets the -4. For the numbers, Again, I'm going to plug them straight into my calculator. 5 times 2 to the negative 4. Math, enter, enter when you get your decimals. And we get 5 over 16. And then the x, we're going to add the exponents now because they're being multiplied. So negative 9 plus negative 4, we get negative 13. Just like with question C, it does not say that you have to simplify with a positive exponent, so you could leave your answer like this. Or just like I did on the last one, we can switch it to the other side to make it positive. Or you can just write it as one big fraction, where the x to the 13th is with the 16 on the bottom. All three mean the same thing. Last one, I'm going to take care of the parentheses first. That negative 1/3 has to go to 3 different things. The x on top already had an exponent, so we're going to multiply together the exponents. So 3 times negative 1/3. You're going to get x to the negative 1. On the bottom, we're going to have 8 to the negative 1/3. I'm going to hold off on that one for a second. I'm just taking care of exponents right now. And then we have negative 6 times negative 1/3. Gets me x to the second. Just like question C, the top technically has a 1 in front. And then we can type this into our calculator. And it comes out as just 2. Then we're going to subtract our exponents. So negative 1 minus 2 gets me negative 3. Just like the last two, we can leave it like this, or you can flip it to make the exponent positive, or you can write it as just one big fraction. Any of those 3 work. Question 2 is doing the same thing that all of question 1 did, with the exception that now at the end we have to have positive exponents. I'm going to start off the same way by taking care of the parentheses. So the top is staying. The 2 on the bottom is outside the parentheses, so it does not get the exponent. And then everything inside already had their own exponents. So now we're going to multiply. So for J, negative 4 times 4, negative 16. For C, negative 1 times 4 is negative 4. From here, dividing, 3 over 2 is just 3 over 2. Exponents, we're going to subtract with division. So for J, be careful, negative 3 minus negative 16 gets me positive 13. And for C, negative 5 minus negative 4 gets me negative 1. It says positive exponents only, so we are going to have to fix this up. The C has a negative exponent, so we can copy everything down and just flip the C. Or you can copy this as one big fraction. Technically, that j to the 13th is over 1. So on top would be 3j to the 13th. And on the bottom is the 2c to the 1st. Question 3 says the graph of f of x equals a to the negative b power will be the same as which of the following graphs? So negative exponents, remember, flip you to the other side. So the a can go to the bottom, and then the exponent turns positive. So this means the same thing as the original. So 1 and 2 are out. They do not have the a in the denominator. For 3 and 4, if I distributed that exponent, the b, I get 1 to the b over a to the b. On top, 1 to the b, 1 to any power, no matter what power I choose, I get just 1 as an answer. On the bottom, a to the b is a to the b. So these are the same. So we get answer choice 3. Question 4, find the product of 2 radical 2 plus 5i and 5 radical 2 minus 2i expressed in simplest a plus bi form. So product means multiply. So I am going to take the 2 and multiply them together. So I need to double distribute. 2 radical 2 times 5 radical 2 is 10 radical 4. 2 radical 2 times negative 2i is negative 4i radical 2. 5i times 5 radical 2 is 25i radical 2. And 5i times negative 2i should be negative 10i squared. Simplifying, the first one, radical 4 is 2, and then 10 times 2 is 20. Combining the like terms in the middle, negative 4i radical 2 plus 25i radical 2 gets me positive 21i radical 2. And negative 10i squared on my calculator is positive 10. I can then combine like terms, and I get 30 plus 21i radical 2 as my final answer. Last one. Algebraically determine whether the function j of x is odd, even, or neither. Now the shortcut was to just look at every x's exponents. If every x has an even exponent, the whole function is even. If every x has an odd exponent, the whole function is odd. If some of the x's have an even exponent and some have an odd, then the function is neither. However, to show this algebraically, the only option is to take j of negative x. So that means everywhere that I have an x, I am plugging in a negative x, and then simplify. Even exponents cancel out the negative. So negative x to the fourth goes back into positive x to the fourth. Negative 3 times negative x squared. Negative x squared is positive x squared. The negative gets canceled. So the negative 3 times x squared is negative 3x squared. And minus 4 comes down as minus 4. So this function is even. And if they ask you to explain why, it's because the entire function remained the same. So switching the sign of x had no effect on the function whatsoever. The whole thing stayed the same. Again, if it says algebraically, this is your only option. If you just tell me the even, which you can tell by the exponents, you would not get full credit.